Right. The first thing I would like you to notice here is that this compass is actually like a little magnet, and that's the north end of the magnet there. Um, and I want you to see what happens when I bring the north end. It's being attracted to the south, it's being pushed away from the north end. So the north end of this magnet is attracted to the south end here, and the south end is attracted to the north. Okay. And I want to go ahead and see what the magnetic field lines look like. I mean, the compass kind of gives us a little bit of a hint, but I want to see what they look like. So we're going to use some iron filings for that. And I'm going to put a piece of paper over it. And this doesn't exactly match up, but that's kind of what you're seeing there. So it's sort of like that. And now I'm going to put some iron filings over the top of this, and I want you to kind of look at the pattern that it makes. So looking at the pattern here, it looks like there's kind of a circular shape here and circular shape here. But more importantly than that is I want you to understand that these magnetic field lines, they have to be continuous. I don't want you to think that they begin here and end over here. That's not true. It's a continuous loop. So I suppose you can say they begin here on the north and they go over to the south, but they don't end here. They actually, if you look very carefully in here, they actually continue back over to the north again. So it forms this D on the outside here, and on the other side, on this side as well, it forms this D. Also, I want you to understand that these magnetic field lines never cross. So when they come back inside here, that line doesn't cross another line. Those are two discrete lines. And out here, they kind of go out this direction. And if we had more room, you'd see that they go on and come back around and loop back on this side and go through the middle. Same thing here. They go out this direction, out the top here, come back around and go back through the middle. Okay. All right. So that was that's what the magnetic field line looks like when you have just one magnet there. Okay. Okay, now what we're going to do is we're going to look at what happens when you have more than one magnet. So first of all, I need to make sure my compass is, or my magnet is properly. So yeah, it looks like a good one to me. So I'm going to put a north and a south end near one another. Okay, so sort of like this. Let's see what it looks like. Okay, first of all, I want you to see, well, they're kind of you can't really tell, but they're kind of attracted together, which kind of makes sense. That's what we saw with the compass needle. But let's look what it looks like on the paper. So you have to remember this is the south and this is the north. I'm not going to redraw it. Okay. I just want to look in this region here. All right. So here's the north. And so you can think of them as starting here and then they loop back through here. So this kind of reminds us of a dipole with kind of like a positive charge and a negative charge. So it kind of looks like a dipole here. These aren't charges, these are poles, but that's what it kind of looks like. So we have these loops through here, okay? So let me clean this up now. So that was a north and a south end. Now let's look at what happens when you have two north ends near one another. And these are not attracted like before. Let's see what the field looks like. So remember, this is two north ends. So it's kind of hard to see this, but it looks like two sets of field lines that are kind of bowing away from one another here. So they're kind of hitting one another and meeting here. So they're kind of going this way, kind of going this way, kind of going this way, kind of going this. This reminds me of two positive charges that were near one another. Okay. And now let's do two south poles near one another. And again, they're not attracting. Okay. All right. So remember, two south poles near one another. Oh, too much. Let me try that again. Oh yeah, this is nice. This is pretty good. This is better even than the north poles, but you can see kind of the same pattern as with the north poles. Now the truth is they're not going out like this, they're actually coming in like this. This is sort of like two negative charges near one another. Okay. All right. So a question we might have is, well, what would happen if you broke one of these magnets in half? You know, we have a north and a south pole. If we broke it in half, would we just have a north pole? Would we just have a south pole? You know, that's what would happen? I mean, I don't know what would happen. So here I actually have a magnet that I broke in half. So I think I labeled this end. Looks like I've labeled it incorrectly. I guess that's really the south end, and that's really the north end. I wonder if it's labeled correctly on the other side. Nope. Anyway, now let's see what happens when I pull this off. So that's really the south end. Okay. So I'm going to bring this over here. You'll see that it's definitely attracted. Oh, look, that's repelled. So that's really a north end. So it's like now I have a little tiny magnet here. So there was that one. I'm going to put that one over here out of the way and bring the other one. If you remember, this was the other half of it. And so this would be the south end. And over here is the north end. So now instead of having one magnet, right, one magnet, now I have two magnets. So that's what happens. So you cannot have a monopole. That's what I've just shown you. I can't just have a north pole or just a south pole. If you split a magnet in half, you're just going to have a smaller magnet that still has a north and a south pole.